I'm Mike, and this is the BenchBot. It's a lab robot. It's to help biologists automate lab tasks. Um, so it's based off of a DoBot robot, which is a 4-axis stepper motor driven robot. It's got 3 stepper motors, one here, here, and here, and one drives the base, which is here, and then one drives the upper arm, and then the other one drives the lower arm, which is here, and then you can attach end effectors. So on the end of this, we have a 3D printed electronic pipetter, and then the robot is controlled by an Arduino, which is hooked up to a RAMPS 1.4 motor shield, and it takes in 12 volts from a power supply, which I have here, and then I'm just using a pigtail adapter to connect from the power supply to the RAMPS board in these 2 slots. Before I demo the application, I want to talk a little more in depth about the hardware. So I guess first we'll start with the robot itself. Okay, so it's made out of an aluminum frame. You can just CNC it. It's only a few millimeters thick. It's got 3 NEMA 17 stepper motors. Each of the stepper motors are connected to a 10-to-1 planetary gearbox. So what this means is that it takes 10 steps of the stepper motor to actually rotate the shaft of the robot one step. So it takes 10 steps of the stepper to rotate the robot one step, and that gives you finer resolution. And then it's shipped with some angle sensors, which are just accelerometers to help initiate the position of the robot, but the angle sensors are prone to drift, and so a better solution would be to use limit switches. So some other people in the DoBot community have used just regular end stops, and they 3D printed a little holder and mounted them onto the arm, or someone else used a photo switch end stop. So it would be good to look into adding those in the future. So on the electronics side, the robot is connected to the stepper motors. So this is just a RAMPS 1.4 board that's commonly used in 3D printers. There's 5 stepper motor slots. Each one takes a A4988 stepper driver, and they just pop in on top of there. There's these 3 sets of pins under each stepper motor. These are micro stepping pins, so they have little jumpers that you can put on here, and depending on the combination of jumpers, you get different micro stepping. So it can be like 1/16 micro stepping. So instead of moving 1 step, when you give the stepper motor a pulse, it'll move 1/16 of a step, so you get finer resolution that way. And I generally drive it with 1/16 micro stepping, so all 3 jumpers attached. This has an I2C pins, so you can add sensors if you want to. If I want to hook up a pressure sensor for the pipetter, I can put that there. And the whole power supply takes 12 volts and 5 amps. I don't think there's much more to say about the RAMPS board other than it's cheap. It's only $10. The Arduino Mega 2560 is equally as cheap. It only has 8 kilobytes of RAM. It's a typo. And then it communicates serially via USB port to just a laptop, where you can hook up a Raspberry Pi, although in the future we're thinking that it might be better to forego the RAMPS 1.4 and the Arduino Mega 2560 and just hook up the Raspberry Pi, since it has some general purpose input-output pins, to just hook those up to the stepper drivers, and that's not a very complicated circuit. And then the Raspberry Pi has 512 megabytes of RAM, I think. So that should remedy some problems we were having sending too many commands to the Arduino, so it couldn't store all of the commands. That's it. Total cost, the ARM I got it for $500 from Kickstarter, but now it's $900. Someone on the Reddit user group quoted saying they could make it themselves for 250, so you could really drive the cost down of the robot. So before I get into the GUI, I'll just briefly explain to you how to set up the robot. So you need to always start it from the same position, and you need to start it from 90 degrees, and you need to unplug the power adapter and then plug it back in, and then it locks in place. And so the way I have the coordinates defined, this is the x-axis, this is positive x, negative x, this is the y-axis, and this is positive y and negative y, and then positive z and negative z. And then the angles are defined such that this upper arm is at 90 degrees. If I rotated it this way, it would be at 0 degrees, and then this lower arm starts at 0 degrees, and if it rotates this way, it's at positive, say, 90 degrees. So to get into the GUI, once you start it up, this is the screen you see. It shows you the serial ports. If you're on a Windows machine, it tries to connect to an Arduino port. There'll be Arduino in the name, and it'll try and connect there, and then it gives you the connection status, it gives you the baud rate, and then if you unplug it or plug in a new port, you can refresh the list and you can change the baud rate and disconnect. And then it has a manual control tab, displays your XYZ coordinates, and then also the corresponding angles of the base, upper arm, and lower arm. It has a move to coordinate box where you can type in coordinates and it'll move there. So if I hit move, the robot will move to the coordinates. You can also enter angles, and it also has increment buttons, so you can step by different increments, and in the boxes you can type in different units. All the units are in millimeters, so if you want to go up 20 millimeters, you just type 20 in the box and then you hit up and it goes up 20 millimeters. If I want to go down, say 60 millimeters, it'll go down 60 millimeters. If I want to go to So this is sending 3000 bytes of data at a time, or 1003 tuples of angles. And so you see it has to delay in between sending the packets. This is sending only 3 bytes at a time, or 1 packet of 1 3-tuple at a time. And it's much smoother, but it's a lot slower because in between sending each packet of data, it has to parse that data and process it. So there's a trade-off when you're limited in memory. You can't just send all the data at once and store it in the Arduino and then loop through and step the motor.
So throughout this project, we were able to do a lot for setting up a framework for developing the BenchBot into something that could be used in everyday lab tasks to automate things like PCR, different things in the cloning process. We implemented a user interface that can be used by non-programmers. We implemented algorithms that allow for the robot to move, which not only helps us but also sets up a framework for the entire DoBot community to build further off of our software and use the DoBot to automate different things. We really did a lot to contribute to the DoBot open source project. We implemented a 3D model view to show the user their workspace, to visualize their workspace. However, moving forward, there's still a lot left to be done. We need better stepper motors, which is going to be shown in the next clip. We're looking to increase the torque and get better high resolution, and also increase our available payload so that we can lift heavier things. And another one of our goals is to improve the serial protocol. Mike discussed this a little bit earlier in the video, but a way that we could do this is by increasing the amount of available RAM that we have. The Arduino currently has 8 kilobytes of RAM while the Raspberry Pi offers 512 megabytes of RAM. So running everything from the Raspberry Pi would improve our ability to send data to send large amounts of data quickly, which would give us we would have an easier time sending instructions to the robot. We could also add more functionality to the GUI, such as adding custom menu items. This would allow developers and biologists to start developing useful tasks so they could. We also need to work on calibrating the BenchBot so that we can use it in a lab setting. We also need to finish the pipetter construction and also calibrate the stepper motor that is controlling the dispense of the liquids so that we know the exact liquid level. This can be done by checking the output of the stepper motor. That would require a few hours of work, but very close to that. I'm going to show you just a quick demo of why we need better stepper motors. It's going to show the DoBot failing when it gets too low and it has too great of a payload. Okay, now it's working. I'm just gonna, yeah.